In this video, we are going to be solving cubic equations, or equations with x cubed in them. But we're going to receive a little bit of help. We're going to be given a factor, and that's going to help us out quite a bit when solving these cubic equations. All right, let's review a few basics before we get really started. Now, this example, we're going to find the zeros of this function here. Notice it's a quadratic function with x squared in it. Now, the zeros, you can think of those as solutions when the polynomial equals 0. Now, to make things even a little bit more confusing, there's another word for a 0 or a solution, and that's a root, or we're finding the roots. So that's a completely different use of the word root, because in this case, it just means a solution when the polynomial equals 0, or a 0. So anyway, let's find the zeros or roots or solutions of this polynomial when it equals 0. All right, so this polynomial looks like it is probably factorable, so let's give it a try. We want two numbers that multiply to make 12 that have a sum of -8. And sure enough, we have -6 times -2 equals +12, and those two numbers have a sum of -8. So this polynomial is factorable, and that's good because it makes it easy to solve. So we break it down into x minus 6 times x minus 2 equals 0. And so we have something times something equals 0. So one of these two things must equal 0. If it's the first thing, then x minus 6 equals 0, or add 6 to both sides, and x equals 6. If it's the second thing that's 0, then x minus 2 must equal 0, which means that x equals 2. So here are our two solutions, x equals 6 and x equals 2. Now let's remind ourselves how that is connected to its graph. This is a quadratic equation, so the graph will be a parabola. And these zeros, or solutions, or roots, tell us where the graph crosses the x-axis. So this parabola will cross the graph at x equals 2 and x equals 6, and a parabola kind of makes that U shape. But then it also looks a little bit like a V as it gets close to the vertex. So the main idea here is that the zeros are related to the x-intercepts of the graph. Now you have probably previously solved cubic equations. Like here we have a cubic function, and we're looking for the zeros, so we're looking for the solutions when this polynomial equals 0. So let's give that a try. Now in this case, we notice that there's a common factor in these three terms. We can factor out or divide out an x from all three terms. So let's go ahead and factor that out. All right, so now we're hoping that this quadratic expression here is factorable. So let's give it a try. We're looking for two numbers that multiply to make -60, that have a sum of 4. 10 times -6 equals -60, and those have a sum of 4. All right, so these numbers on the side will help us with our factors here. So we have this x still, and one of the factors of this trinomial here is x plus 10. That comes from this 10 here. And the other factor will be x minus 6. That comes from here. And it still equals 0. So we just rewrote this original equation in factored form. And now we can find the solutions, or the zeros, which are also called the roots. Well, let's see, we have something times something times something equals 0. Now, if this first thing equals 0, this one is so easy it's difficult, then x must equal 0. If it's the second piece that's 0, then let's see, x plus 10 equals 0, which means that x must equal negative 10 because we subtract 10 on both sides to solve for x. And if it's the third thing that's 0, then x minus 6 must equal 0. Add 6 to both sides and get x equals 6. So we have x equals 0, x equals negative 10, and x equals 6. So to solve this equation, we factored out an x, which made it much easier to find the other factors. And I looked up on Desmos what this graph looks like, and let's take a quick peek at that, because it's related to some things we'll be talking about shortly. Now, these zeros here, remember we discussed previously, also are the x-intercepts. So we have an x-intercept at negative 10, which will be somewhere over here, just making a rough sketch. X equals 0, that'll be at the origin, and x equals 6. That'll be like around here. And on Desmos, this graph looks something like this. It went up and then came down and then back up. Right, so in this case, we have 3 solutions and 3 x-intercepts. One last thing I'd like to review before we dive into the main event is synthetic division. We'll be using that today. So first of all, let's look at our first polynomial here and look at the coefficients. We remember there's a 1 in front of that n cubed. Let's start by listing out the coefficients, and if there are any missing terms, we would include zeros there. There are not any missing terms here though, so we'll just list out 1, negative 2, 4, and negative 4. And then we kind of make this little bracket here, leave a little space here. And then to the left, we put a 0. Now, here's a factor. And if n minus 1 is a factor, we can set that equal to 0 to get the 0. So 1 is a 0 of this polynomial here. So on the outside, just to the left, I'll put a 1. All right, step 1 is to bring down this first coefficient, and then we multiply. 1 times 1 equals 1, and we'll put that underneath the negative 2 in this case. So I got this 1 here by multiplying 1 times 1. Now we add. Negative 2 plus 1 is negative 1. Now we multiply again. 1 times negative 1 is negative 1. Now we add. 4 plus negative 1 is 3. And we multiply. 3 times 1, always by this 0 here. So 1 times 3 is 3. It goes here, and we add. Now this last number here is the remainder. So n cubed minus 2n squared plus 4n minus 4 divided by n minus 1, well, that equals, see, this is n squared, or 1n squared, minus 1n plus 3. This is a negative number here, so it'll be minus 1 over n minus 1. If you'd like some more practice with synthetic division, then take a moment to pause this video and find a different video that gives you some more review with synthetic division. Okay, we've arrived at the main event. So in this example, we're going to solve x cubed plus 2x squared minus 20x plus 24 equals 0. Notice there are not any common factors that we can factor out. And they're telling us here one of the factors of the polynomial is x plus 6. So in a problem like this, where we know one of the factors, well, we can use synthetic division to divide by the 0 related to this factor. And that's going to break down this cubic expression into a quadratic expression. So let's see how that works. So let's start with the synthetic division. I'm going to list out the coefficients of each term. I notice there are not any missing terms. So that would be 1, 2, negative 20, and 24. Make my little bracket. I want the 0 associated with x plus 6. So I just subtract 6 on both sides, and the 0 would be negative 6. All right, so that's what goes over on the outside here to the left. That's the 0 related to this factor. And I start by bringing down the 1 in this case. And then I multiply. 1 times negative 6. And then I add. 2 plus negative 6 is negative 4. And then I multiply. Negative 4 times negative 6 is positive 24. And I add. Negative 20 plus 24 is 4. Then I multiply. 4 times negative 6 is negative 24. Add and get 0. So we have a remainder of 0. And actually, we knew that going in here because we knew that x plus 6 was a factor. All right, so let's rewrite what we have so far. So we're going to rewrite x cubed plus 2x squared minus 20x plus 24 as a product of two factors. One of the factors is x plus 6. And the other factor that we just learned is, let's see, this 1 represents 1x squared. This negative 4 represents negative 4x. And this 4 represents a 4. And then this whole polynomial equals 0, and this product of two factors is the same as this polynomial, so it still equals 0. These two zeros are unrelated. This is just the remainder, and this is what the equation equals from up here. Okay, so let's see. So now we have this trinomial here, and we're hoping that it's factorable. So let's give it a try. So we want two numbers that multiply to make positive 4 that have a sum of negative 4. Well, that would be negative 2 times negative 2. All right, so we can rewrite this equation as x plus 6 times x minus 2 squared, because the wing numbers here are negative 2 and negative 2. So that would represent x minus 2 squared, and it still equals 0. All right, remember we're trying to solve this equation, which means we're also finding the roots or the zeros. Those are all different ways of saying this. So let's see here. With something times something squared equals 0. So one of these two things must be 0. If it's the first thing, then x must equal negative 6. So that's what makes this binomial 0. And if the second thing is 0, then x must equal positive 2. Because that would make x minus 2 equal to 0. Now this x minus 2 is a special solution. We can call this a double root, since it appears twice. It's x minus 2 times x minus 2. And that will be somewhat relevant as we move forward in our discussion. All right, so we have two solutions here. Now, once again, let's take a peek at a sketch, a very rough sketch of what this graph looks like. Now, this x equals negative 6, that is also an x-intercept. We'll just kind of estimate about where that goes. And x equals 2 is also an x-intercept. This one turns out to be sort of a special x-intercept, as you'll see in a moment. And when I graph this on Desmos, it looks something like this. It kind of came up, and then that x equals 2 is the kind of the local minimum here where the graph changes directions. So we have our two zeros here, which were the solutions to this equation. All right, same sort of thing here. I'm just using some different wording to this question. So we have the polynomial f of x equals x cubed minus 3x squared plus 5x minus 6 has a 0 of x equals 2, where f of 2 equals 0. Find the other zeros of this function. Right, now first of all, let me point out that this expression here, we have a 0 of x equals 2. That means the exact same thing as this, pretty much. So what this means is that when x equals 2, the y equals 0. And what this tells us is that when the input is 2, or in other words, when the x is 2, the output is 0, or the y is 0. Okay, so really what we're trying to do is we're going to set this polynomial equal to 0, and we're going to solve that equation. All right, now we know that one of the zeros is x equals 2. Okay, so let's think about what the factor related to this 0 would be. Well, the 0 is x equals 2. Then the factor must be x minus 2. Because to get this x equals 2, let's see, that was a 0, so the factor equals 0. You would add 2 to both sides to get this. So we kind of work backwards from the 0 to get the matching factor of x minus 2. All right, so now we know one of the factors. Let's go ahead and use synthetic division to divide this polynomial by x minus 2. So I'm going to list out the coefficients of this polynomial first, so that we understand there's a 1 in front of that x cubed. The 0 is 2, so that goes out here. I bring down 1, and then I multiply. 1 times 2 is 2. And I add. And I multiply. Negative 1 times 2. And I add. And I multiply. 3 times 2 is 6. And we get a remainder of 0. In this situation, if we don't get a remainder of 0, then we know something's wrong. Because we already knew that x minus 2 is a factor of this polynomial, so it should have a remainder of 0. Now we know that this polynomial is the same thing as x minus 2 times, now I'm going back to this, x squared minus 1x plus 3. That still equals 0. All right, this is better. So now let's try to factor this trinomial to see if we can find some more factors. So I want two numbers that multiply to make 3 that have a sum of negative 1. Well, let's see here. To get 3, that would be 3 times 1. And there's no way to add or subtract a 3 and a 1 to get a negative 1. So unfortunately, this trinomial is not factorable. Okay, but we are trying to find the zeros. And see, we already know one of them. We know that x equals 2. Or let's just write it this way. X minus 2 equals 0. Well, we have something times something equals 0. So now we need to figure out what x makes this trinomial equal to 0. X squared minus x plus 3 equals 0. All right, so in other words, we're trying to solve this equation. And factoring didn't work, so let's try the quadratic formula. And if you'd like some extra practice with the quadratic formula, you can go to YouTube and check out some more videos there. So the quadratic formula says x equals negative b, or the opposite of b. Well, in this case, b is negative 1. So that would be the opposite of b plus or minus the square root of b squared minus 4, always 4, times a times c. All of that over 2 times a. The a was 1, the b was negative 1, and the c was 3. Working out the part inside the square root, let's see, we have 1 plus or minus the square root of negative 1 squared is 1. We have negative times a positive times a positive. This will be negative, so it'll be 4 times 1 is 3, which is 12. So 1 minus 12. All of that over 2. Let's simplify what we have in the square root here. 1 plus or minus the square root of negative 11. All of that over 2. Now, using real numbers, there is no square root of negative 11. Because a negative times a negative is positive. So there's no way to multiply a number by itself to get negative 11. But if we expand our universe to include the imaginary numbers, the square root of negative 11 equals the square root of negative 1 times the square root of positive 11. And we have a special imaginary number for the square root of negative 1. It equals I. So this is 1 plus or minus I times the square root of positive 11 all over 2. So we have two imaginary roots for this question, or for this equation. All right, so remember we had this factor of x minus 2. And so when we have something times something equals 0. So if this is 0, then x must equal 2. Well, here we went ahead and solved this trinomial for 0, and we got x equals 1 plus I times the square root of 11 over 2. And x equals 1 minus I times the square root of 11 over 2. So we have our zeros. Now, I took a look at the graph on Desmos. Interesting graph here. And we know that it has an x-intercept of 2. Now, these two numbers are imaginary numbers. So those are not x-intercepts because the x-axis does not have imaginary numbers on it. It has real numbers on it. And so these two zeros are zeros, but we call them complex zeros. And this 0 here is a real 0. And anyway, when Desmos showed the graph, look, something like this. The graph was coming up. It kind of had a little bobble here and then continued back up. So here we have 3 zeros, but only one of those turned out to be an x-intercept. All right, one last thing here. Let's find the zeros of this function, or we'll be solving this polynomial when it's set equal to 0. And we're going to use the graph to help us. So instead of being told a 0 or a factor, here we're just given a graph. All right, well, this point here is going to be key because it tells us an x-intercept. Now, this x-intercept here, let's see, that is a real number, but it's a little hard to tell exactly where that is. Same with this x-intercept. It's a real number, but we don't know really exactly what it is. All right, so let's figure out what these two other zeros are. So first of all, I'm going to set this equation or this polynomial equal to 0 because we're finding the zeros, which are the solutions when the polynomial equals 0, or that you'll also hear people call those the roots. So be on the lookout for that, unrelated to the square root. All right, we already know that we have an x-intercept of negative 4. So x equals negative 4. That is a 0, and it corresponds to the root, or pardon me, to the factor of x plus 4. So if I add 4 to both sides here, I'd have x plus 4 equals 0. All right, so we have x plus 4 times some polynomial that we don't know yet equals 0. Okay, let's use synthetic division to try to figure out what this polynomial is here. So I'm going to write out the coefficients of this polynomial in order. So that would be 1, 2, negative 12, and negative 16. Set up my little bracket. The 0 is negative 4. That goes on the outside. I bring down the 1. Multiply. Add. And multiply. Add. And multiply. And as expected, we get a remainder of 0. If we don't, we made a mistake somewhere. All right, so these numbers here tell us the coefficients of x squared and the x's and the constants. So we divided x cubed plus 2x squared minus 12x minus 16 by x plus 4. and we got this trinomial here. Okay, so once again, let's try to do this the easy way and factor this trinomial. So we want two numbers that multiply to make -4, that have a sum of -2, and unfortunately, once again, that's impossible. So once again, let's use the quadratic formula to solve this trinomial set equal to 0, and we'll find those two other zeros, or x-intercepts, that way. All right, see if I can squeeze it in down here. So the quadratic formula on this trinomial, a is 1, b is -2, and c is -4. So x equals the opposite of b. So the opposite of -2 is +2, plus or minus the square root of b squared, minus 4, always 4, times a, which is 1, times c, which is -4. All of that over 2 times a. Let's simplify under the square root sign. So we have -2 squared is 4. Let's see, we have negative times negative, that's going to be positive. And see, when we multiply these out, we get 16. So it'll be positive 16. All that over 2. Simplify this, and we get 2 plus or minus the square root of 20 over 2. Now the square root of 20, I'm running out of room, so I'm going to simplify the square root of 20 over here. That's equal to the square root of 4 times the square root of 5. And the reason why I broke it down that way is because the square root of 4 is a perfect square root. So the square root of the square root of 4 equals a plain old 2. But it still has that square root of 5 attached. All right, so we have 2 plus or minus 2 times the square root of 5. All that over 2. Right, all three of these terms are divisible by 2. So I'll divide the numerator and denominator by 2. Then we end up with, let's see, the denominator is going to go away because we end up with 1 in the denominator, which means that we don't really need it anymore. So we have 2 divided by 2 is 1, plus or minus, and then 2 divided by 2 is 1, so those 2's kind of cancel, leaving us with the square root of 5. And so we now have our zeros. So the 0 for x plus 4, let's see, well, that was the number that makes x plus 4 equal 0, which is -4. That's one of our zeros. And then we have 1 plus the square root of 5, that's another 0, and 1 minus the square root of 5. So we have 3 real roots, or 3 real zeros. And they appear on our graph as these x-intercepts here. In this video, we solved cubic equations given a factor. We did that by dividing by that factor, and then either continuing to factor or using the quadratic formula to solve the trinomial equal to 0. I hope these examples have been helpful. This is Mr. Ela signing off.